Here's a model we sometimes use when we're first learning about fractions. We call it egg carton fractions. Take a look at this egg carton over here. Count how many eggs you see in the carton. 1, 2, 3, 4, 5, 6, 7, 8. How many total eggs could be in this carton? We know a carton of eggs holds a dozen eggs, which is 12. So one way that we could represent how many eggs there are in this set right now is 8/12. 12 that could fit in our carton. What if we did something a little different with our eggs? What if instead of having 12 sections where the eggs could fit, what if I used some dividers to divide up this carton? One way I could divide it is here and here. These are equal sections. 4 eggs can be in this section, 4 eggs could be in this section, and 4 eggs could be in this section. How many total sections do I have now? 1, 2, 3. So this time when I write my fraction, my denominator is going to be a 3. There are 3 possible sections that my eggs can be in. How many of these sections are filled? This section is filled, this section is filled, this section is not. 2 of the 3 sections of the egg carton are filled. So when I write the fraction 8/12, that's the same as 2/3. I'm just putting more groups together to make less sections. Is there another way I can do this? Let's take a look. What if instead, I'm going to keep my 2 sections here, and this time I'm going to split the egg carton also down the middle horizontally. How many sections do I have now? 1, 2, 3, 4, 5, 6. Each section could have 2 eggs. So we now have 6 sections. How many of those sections are filled with eggs? 1, 2, 3, 4. These 2 are not. So this fraction can be represented as 4/6. 4 out of 6 sections are full. What this tells me is that 8/12 is equal to 2/3, which is equal to 4/6. How can this be? It can be because we changed the size of the section each time. We had the same number of eggs every single time, but the way that we grouped the eggs in single eggs, groups of 4, or in groups of 2, it changed how we could write that number.